capital components of the industry. He has a good experience in working with different softwares for econometric analysis like eView, Stata, R programming, etc. He has good knowledge on using referencing software like Mendeley, EndNote, and he is currently investigating the institutional determinants of OECD countries, FDI inflows, and also he is examining the relative importance of the factors by using the machine learning classifiers through Python programming. With the few credentials that I have with me, I have the pleasure in welcoming my own friend, Dr. Abuzar Nomani, to the technical session 11, and he will be dealing with the topic that he is supposed to. Welcome you, sir, and over to you, sir.
Thank you, Prasad.
Very thankful to you, Dr. S. Prasad, sir, and I'm very delighted to be on this platform, and I would like to welcome again all the participants here, and I just want to giving a thanks to the Department of International Business for organizing such a big FDP program. And on a topic like very burning topic recent days. And I would like to thank the HOD of this International Business Department, Dr. Muthuswamy sir, that he has taken the responsibility to organize such a big event in this department. So as we have already having a lots of sessions regarding this blockchain and all that things. So when we are talking about the blockchain, dear participants, I just need your focus and concentration, because when we're talking about the blockchain, what the thing is that without the artificial intelligence and machine learning, this blockchain will not work. Okay, so while going through understanding the blockchain and FinTech, when we are using in the banking industries and the finance industry, we must understand the basics of artificial intelligence and machine learning. That's why with this concentration, with this motive, we have added a small introductory level of AI and machine learning to this FDP program, so that you may not skip, or you may not feel unaware about this particular topic. Okay, so here in this on this platform, I'm not going to discuss with you as a computer science background or the technicality of that artificial intelligence and machine learning. I'm just giving you starting this topic from zero, very zero, so that those who are new to the artificial intelligence and machine learning, they don't know anything about the machine learning and artificial intelligence, they can easily understand. And I'm not going to use the terminologies and the words that are using in the artificial intelligence and machine learning. Instead, I'm using the words that are very comfortable to both of them. Okay, so here the topic that we are going to discuss is artificial intelligence and machine learning, and there what we can say the introduction and history. And apart from introduction and history, I'm giving you that how can you use this artificial intelligence and machine learning in solving your problems, and how can you use artificial intelligence and machine learning in using your research work. How can you use in your research work the data that you are coming with in through the questionnaires or the secondary sources of data, that how can you use the artificial intelligence and machine learning models for your research work. So let us start with it, with today's agenda, that what we are going to discuss in this session. I'm starting with an introduction of artificial intelligence, machine learning, and one more word that recently has been very in a very boom these days, that is deep learning. And thereafter, after the introduction of these three, we will discuss about the history of them, artificial intelligence. And then we will discuss the type of machine learning, what are the various types of machine learning that we are going to use these days. And thereafter, we have a discussion on algorithms. What are the algorithms of the machine learning that we are using it? So I just need your responses whether you are acceptable with the today's agenda. So we can take it.
Yes, sir, it's totally fine.
So we are just moving ahead with that. So when we are coming towards the artificial intelligence, machine learning, deep learning, it's create a confusion, a big confusion that what is AI, what is machine learning, and what is deep learning. So in a single words, I just need to remove your confusion that all the three of them, the artificial intelligence, the machine learning, and the deep learning are the subsets of each other. If we are taking the broad field of artificial intelligence, the machine learning and the deep learning will come under it. So without machine learning and deep learning, we cannot identify the artificial intelligence. Okay, and the artificial intelligence has been composed of these sub blocks, the machine learning and the deep learning in that. So a very first level, I just need make you clear that there is a difference among them, but they are interrelated with each other: the artificial intelligence, machine learning, and the deep learning. So I think that this confusion of machine learning and artificial intelligence and deep learning is little bit clear to you. Now I just give you a brief history of the artificial intelligence, how it came to existence, what is the reason of using the artificial intelligence, what are the things that we are considering it, and how in the modern day will it work. Okay, so this is the thing that we are going to discuss today. So artificial intelligence is being first introduced in around 1950s and 16s, especially we can say it is in 1956. And the reason of using the artificial intelligence is the only reason is the data. What is the data? Why it is the data? Because earlier it was seems that we are using only
session class A interface.
Yes, anyone asking something?
No, sir, you can proceed.
Okay, thank you. So the reason is data. So earlier we are seeing that we are using only a few limited numbers of data, that comes in 1 GB or 2 GB or 3 GB. Now, as the world has become digitalized, more transparency they are proceeding towards. So the data has been increases drastically, and nowadays 44 zettabytes which is equal to 44 trillion of GBs data we are using every day in every enterprises. So how can we deal with that huge data? That's why the one study has came to with the name of big data. So how can we arrange these data? Because a human cannot possible to dealt with that data, because when we are working on the Excel, we are facing number of problems, and to solve that problems, to overcome of that problems in Excel, we use macros. Okay, so macros is what? Macros is also a algorithm that we have developed a very basic level. So for that, how can we dealt with the huge number of data who are is in number of 44 trillion GBs, we can say. So we need a algorithm for that, advanced algorithm we need, and we also need a high-end computing power, because the calculators will not compute on that things. They have a limited computing power, and also a bigger storage we need. So this is the reason why the artificial intelligence came into existence. when we are talking about the artificial intelligence in 1950s and 1960s, it was think that artificial intelligence is like making the robots. It's a mechanical work. We put the buttons, they will do all the things. But when the studies for the researchers has been made, and it is drastically changes in 1980s, it was when it was linked with the statistics, and when it was linked with the using the probability theory, and some logics has been introduced, then a new term has been coined, is called as machine learning. Machine learning means how can we make the machine to learn themselves from their experiences. Thereafter, when the this statistical methods and all that things has been used daily in the machine learning, then it was again been developed as a deep learning, in which the machine itself, the necessity has been arises from the recent days, that how can a machine can be think like a human, because humans can take the decisions from their experiences, but a machine cannot take the decisions. So how this new field has been developed, that is called the deep learning, in which we make the machines to take the decisions. So new fields has been came into existence. So this is a brief history that I have just elaborated before you. I think everyone has clearing the concepts regarding the artificial intelligence, the machine learning, and the deep learning.
Yes, sir, it's clear.
Before going ahead, it's a long video, but I'm just giving you a very short video of this. This is the man that I'm going to share with you, because it is important for me, and without giving a proper sharing of this man, we cannot go beyond any session of artificial intelligence. He's the godfather of the artificial intelligence. You just for the giving a respect to that man, I'm playing this video for you, so that you can know who is that man who is behind the artificial intelligence.
This jackie, because of a back condition, hasn't been able to sit down in more than 12 years. I hate standing. I sit down. Sorry. Well, standing for fashionable. Standing. Can't sit in a car or on a Hinton walks. Walk says a lot about it. So, nearly 40 years trying to get more like people. West almost everyone thought was crazy, or at least hoping. Until the moment to revolutionize the people. Google thinks this is the future of the company.
Sir, sorry to interrupt.
So this is a short introduction of this man that who is behind the this artificial intelligence who is making, and you can see the hard work that is from the last 12 years. He is not able to sit on the chair; he is standing on the. So this is the man who is behind this artificial intelligence. So now, what is artificial intelligence? When the thing is come, how can we define, or what actually we can say about artificial intelligence? In my perspective, artificial intelligence is limitless. Okay, artificial intelligence has no limits. You can go beyond the borders. So artificial intelligence, it's a technique, definitely, which enables the machine to behave like a human, okay, to mimic the human behavior, because we are giving an intelligence to the scrap. What is the robot? Scrap. We are putting an intelligence, a brain inside the machine. So this is artificial intelligence. And artificial intelligence making techniques through which a machine can make the decision. And how he is going to make the decision, we can define artificial intelligence as a experience. Machine, how can take the decision? It learns from the experience. How can human takes the decision? How can we take the decision? Similarly, we have to apply to the machines also. We taking the decisions on the basis of our experiences. Someday we know that the fire will burn you. So you have a bad experience with the fire. So you will not go to touch the fire again. So this is the experience that we have. Similarly, we are going to apply all these things to the machines also. So AI is a technique which enables the machine to learn from their experiences. Okay, so the artificial intelligence can also can be trained to accomplish a specific task. We are going to train through the artificial intelligence. We are going to train the machine to perform or accomplish a specific task by processing. Here, the important thing that is going to be make the artificial intelligence by processing a large amount of data. And from that large amount of data, what we are going to find out, we are going to find out or recognizing patterns in that. And after recognizing the patterns, we make the decision. The machines will make the decision. Okay, so this is all the definition. How can we define the artificial intelligence? Let's take an example of artificial intelligence. Why I told you that it is a limitless, because when we take example of artificial intelligence as any big we can say that suppose you at that era of time you are building the Taj Mahal. Okay, big projects, every big projects we can take here. I'm taking here the Taj Mahal because it's a unique architectures in the world. So as an AI scientist, as an AI student, as an AI faculty, we are just a humble bricks to that project. We are just a humble bricks in that project, whose job is to build a component. Suppose in that Taj Mahal, there are lots of workers are there. And because it was a big project, so everyone is feeling proud that we are being a part of that project. Okay, and someone is putting the bricks on them. Someone putting the marble on that. Someone putting some different works has been assigned to various workers. Similarly, in AI, we are assigning different algorithms, parts, planner, learning algorithm, or accepting anything. Why we are going to do this one on a smaller basis? We are doing all the things on a very small basis. We are programming it. We are then connecting with others. Why we are doing that? That someday someone somewhere will integrate into the intelligent system, that it will work as an intelligent body. Understand? So here some of the examples we have already been seeing is that Apple series, we have seen that the chess playing computers we are having in that Tesla self-driving car is a recent examples of the artificial intelligence. Now, after defining the artificial intelligence, let's come to the machine learning. As I told you, all of three are the subsets of each other, and they are very much interconnected with each other. So when we are going to ask what machine learning is, how can we define the machine learning? So before going to define that, we have a questions before 1960 that the questions, can machine thinks? We are thinking like that. Can machine thinks? Can machine take the decision? Can machine understand the behaviors of the human? But now we have replaced this question, can machine do what we can do, what the human can do? Now the questions has been clarified. We don't have the questions, can machine thinks, Now, the question is very practical. Can machine do the things that a human can do? So machine learning is the field of these answers of all that questions. The field of study that gives computer the ability to learn without being explicitly programmed. That is being defined by the Arthur Samuel. What? It is a field that gives computer the ability to learn without being explicitly programmed. Now, right now, what we are doing, we are programming the computers. But what is machine learning? Without programming, how can it work? Without putting the buttons, how the computer will on, how power button, without pressing that button. So this is machine learning. So machine learning is a subset of artificial intelligence which enables the computer to act and make data-driven decisions to carry out a certain task. Okay, so what the machines are going to do in the machine learning, they are recognizing the pattern. Computational learning they are going to do, and what more we can we can ask the machines to do. They are predicting. We can make the predictions from the previous experiences. We can make the predictions for the futures, and we can explore the data with this machine learning, and also predictive analysis and predictive modelings we can expect from this machine learning. So machine learning came into existence in the late of the 1980s and 1990s. The existence is totally depend upon the issues. Why it came into existence? There are certain issues that people are facing, and that create a necessity of the machine learning. And what that issues people are facing and the societies are facing that lead to the generation of the machine learning. That when it is comes to how efficiently train large complex model, because the statisticians, those who are studying the subject of statistics, they came across a problems of a large data that they are not able to solve. So how effectively can train the large complex model? This is the problem of the statistician when we are thinking, when we are taking the discipline of the machine learning as a statistics. The second is how to train more robust version of artificial intelligence. When we are talking about the computer science as a subject of machine learning, over there we have found a certain problems that how can we train the more robust version of artificial intelligence. So this is the problem for that leads to the generation of the machine learning subject. When we are talking about the neuroscience, they have there is a requirement that how to design an operational model of the brain. How can we design the operational model of the brain? For that, they have there is a need of a study of machine learning. So machine learning comes not only from the field of the engineering, but it is a part of statistics also, computer science also, and also from the neuroscience. So that's why its acceptability is also in all the different fields. So machine learning, thereafter, after the 1990s, it's shifted its focus from the symbolic approach that machine learning means robots and all that things. It shifted its approach, and it had inherited from artificial intelligence. It linked with the artificial intelligence by using or borrowing the methods from the statistics and probability, because statistics and probability will give them the logic to take the decisions. So that's why today's machine learning and artificial intelligence are going hand in hand together and doing the things that in the past it was not possible. So that's why I'm saying that machine learning has limitless. Now comes to deep learning. What is deep learning? I have given the description of the artificial intelligence. I have given the descriptions regarding the machine learning. Now let's come to the deep learning. Deep learning is a particular kind of machine learning in which you are going to be inspired by the functionality of your brain, and you are going to copy that how the human brain is working. You are going to copy with them, because we know already that our brain is composed of number of neurons in that, which leads to make you transfer of information from your body organs to the brain. Similarly, here in the deep learning, what we are going to do, we are inspired with that, and we are creating a neurons of artificial network, and neurons of artificial networks from whole of the surroundings of your environment. It collects the information, transmit the information to the central processing body that is called artificial brain, and over there they are using some machine learning algorithms to find out certain solutions of the problem, and then transmitting again the information in the form of decision to the surroundings. That is called deep learning. Understand?
Yes, sir.
Sorry, sir.
So what our brain is going to do, similarly, this deep learning is going to make it. The complex task is broken into the simpler task, automatically find out the features, what are the features, who is going to benefit you, who is going to harm you. Suppose I'm giving you the example here, that how can you, here it is a square, you in front of you, there is a box square, okay? And how can you identify that this is a square? How your brain is going to identify that it is a square? I'm just putting a question in front of you.
With the properties of square.
Because your brain is going to break this complex task into a simpler task, and that you are going to find out the properties of the square, that there will be the 4 sides. So first you are going to check that whether this figure is having the 4 sides or not. If it is yes, then go ahead. Now the second property, all the sides are closed with each other. So second task that you are going to check, it is like all the sides are closed with each other. Now it's closed. Now next is all the sides of the square should be perpendicular on each other. Now it's perpendicular, you go ahead, all the sides must be equal with it. So after seeing all these parameters, your brain suggests that it's a square. So what the deep learning is going to do, it's the same thing the deep learning is going to do. It broke in the complex task in a very simpler task, and how can this complex task is broken into the simpler task? By identifying the various features, like we have identified in case of a square. So similarly, they are going to break it into the simpler task. So this is the way a deep learning is taking collecting the informations from the surrounding through the neurons, artificial neurons, and then transmitting again the decisions through these neurons to the surrounding. Understand?
Yes, sir.
Now, here the important thing that we have to discuss is the machine learning. As I have given you a brief introduction of the machine learning and discuss all the history of the machine learning and all approaches. Now, what are the various types of machine learning? This is a very important thing that we have to discuss here. And because we have a very limited time, session is only for the limited time, and the things that we have to discuss is very broad. Even if you studied it for the whole year, you will not be finished over here. So we have to be little concise on that. What we have to do here, we have to be concise, so that in a very briefly I can communicate the important things that makes you aware of the machine learning. So machine learning, the various types of machine learnings is there. So I just giving you a path here that how can we differentiate the various machine learning on the basis of the definition, on the type of the problem that we are going to take. Then we are differentiating on the basis of type of data, then training, aim, approach, output feedback, popular algorithms, and then applications of machine learning. On these basis, I will give you the various different types of machine learning models to you. Okay, so let's taking one by one each. So with the definition, we can classify the machine learning basically in three aspects: the supervised, unsupervised, and reinforcement. Okay, so these are the three learning patterns of the machine learning: the supervised learning method, unsupervised learning method, and reinforcement learning method. In supervised learning method is a type in which the machine is putting the data in the form of labeled data, and the answer or the output is also a labeled one. What is labeled here? It means that it is a very primary machine learning concept, the supervised learning. It is like that you are ordering the machines to do this, to do this, to do this. It is a very primary level of machine learning, that you have ordered the machine with the labeled things, that this is your data, and the output, what is going to be achieved, you already know, and it was put it to the machine that this is your answer. Like that, you are going to be supervised learning. So in supervised learning, we can take the examples like the supervisors are there. Okay, so supervisors are there in the factory to manage the workers. They are ordering the things to do that things only. There is a proper SOP for that. Procedures are there. The humans are also only following that procedures, and the supervisor already know what is the raw material and what will be the finished product in that case. So similarly, the supervised learning is that in which the machine the machine using a labeled data and input both are labeled in that. Understand? So here, guys, we are going to supervised learning. In case of unsupervised learning, the learning over here, the data provided to the machine is not labeled. Okay, the input, the data that is given to the machine is not labeled, and the machine has to learn without any supervision. So no teacher is there. Okay, no supervisor is there. So that machine, why it should discover hidden patterns and trends in that data. Okay, identifying the hidden patterns and trend in that data. So the machine itself finding out some patterns in that, on the basis of the similarity of the data, on the basis of the associations in the data. So the machine himself finding out certain, making certain logics in it and finding out a particular patterns in that data and putting an answer on that. So this is called an unsupervised learning. What is a reinforcement learning? In the reinforcement learning, that there is an agent. Now this agent is put it into an unknown environment, which is in a layman, I just need to make you understand that what is reinforcement. Reinforcement means that you don't have to give any data to the machine, and you don't have to any label data. Any kind of information is not required by the machine. The machine itself collect the information from the surroundings. Okay, and explore the environment by taking actions and transiting from one state to other so that he can get maximum rewards. What is that? If the machine is taking the experiences outside environment, interacting with the outside environment and collecting the information, and on that information, they are taking certain decisions, whether it is bad or right or wrong. Okay, so on the basis of experience, they are collecting the information from the environment, and then after taking the time of experiences, then after the machine is able to take the decisions. So this is called the supervised, unsupervised, and reinforcement methods of learning, types of machine learning. Understand?
Yes, sir.
Now comes to the problem. What kind of problems we are taking in these types of machine learning, that supervised, unsupervised, and reinforcement. So the problem is that when we are talking about the supervised learning, here it is important to for the researchers, those who are interested in doing the research in artificial intelligence and machine learning. Here they can use these things, the type of problem, because when we are having a data, we are every researcher is collecting the data. So is it possible, everyone is asking about, we are doing the researches in the management, and whether we are able to use the machine learning techniques in our research or not. So this is answers to them also, that if you are able to identify your data, that what kind of data you are using in your research, you are able to identify which kind of machine learning method you can apply. So here in the supervised learning, we have two kind of problems we are having. We are having two kinds of situations, whether we can use the regression method or we can use the classification method. Why we are classifying them? Because here we are putting, as I told you, here we are putting only the label data. The label data means that suppose I'm just giving you an example of, suppose you are giving a computer some images of cats and dog, and you put it that this one is cat and this one is dog, and now you ask machine to classify all that images into cats and dogs. So what it means, that you are put it the input data as a label data and output also as a label data. What the machine has to do, a very simple task, just to assemble them. In cat, the cat figure should become in cat, and the dog figures comes in dog side. So this is called the supervised learning. Here you have given them the data as a label data, and you need to make them classify. I'm giving one more example for the classification. So in these kinds of data, you can use regression or classification. Okay, so what is classification? Suppose you have the mails in your inbox. Okay, so some mails are important to you, some mails are not important to you, some mails are spam to you. How this inbox is classifying these things? It is using this machine learning, the classification, because you have already labeled that this mail is spam to you and this mail is important to you. It goes to the inbox and the other one goes to the spam. So this is called the classification. Okay, we are categorizing the data in two different parts. So classification may be in bilateral or multilateral classifications. We can do more than two. Okay, so when the data is like that, the variables are like that. But when the variables are continuous, means in quantity, that is not any limit, like the weights you can take, the average human weights you can take, or the stock price you can take. In that case, the variables, that the data you have collected is in the form of continuous. Okay, that some stock prices is 1 rupee, some stock prices is 1.2 rupees, some stock prices is 4 rupees. So unlimited number of continuancy is there. So in that case, in that type of data, we are going to use the regression algorithm models for the machine learning. Understand? Now comes to the unsupervised learning. Unsupervised learning, here we are giving the problems of association and clustering. In association, what we are going to do, we are finding out, because I have already told you that in unsupervised learning, the data is not labeled. Okay, we are providing unlabeled data to the machine, and machine himself identifies certain patterns in that. So what the machine is going to do, either the machine is going to find certain association, discovering the patterns in the data and finding co-occurrence and so on, and similarities on them, and classify this on the basis of association, or they may cluster. Anomalies detection problem, clustering is used for the case that involves in that. So clustering is there. The machine can make similar groups of similar items, 3-4 groups that can make. Suppose you have a red ball, blue ball, green ball is there, a lot of balls is there, 3 class. So what you are going to do, you are cluster them, the green balls put together, the blue balls put together, the red balls put together. Similar things will be doing in the clustering. Okay, so these are the two algorithms, association algorithms and clustering algorithms we can use for the unsupervised learning here. Now comes to the reinforcement technique type of machine learning. In reinforcement type of machine learning, what we are going to do, we are putting the rewards and punishments, good or the bad. Because here we are not providing any kind of information to the machine. The machine is being left alone into the environment, and from their environment interaction, they will collect the information, and on that information, they will earn the experiences, whether the good experiences or the bad experiences. And on that basis, the machine will take the decision. The machine will definitely go far from the bad and comes nearest to the good. So rewards and punishment, as more and more rewards and punishment the machine will earn, the more experience will the machine gain, and it's more effective decisions the machine will able to take. Now comes to better class, make you more aware about these classifications and regression, association and clustering and reinforcement. One more time, I'm giving you some examples. The classification in here on the one side, it is being shown that to you. The classification is about predicting a label or a class. Okay, example, classify your emails into 2 different routes. So here, basically, we will be labeling our emails as a spam or a non-spam mails for this kind of problems. Here we have to assign input data into different classes. We make use of classification algorithms. There are a number of classification algorithms. We will give you the list of that algorithms, because here we will not have so much time to discuss all the algorithms here. So just classifying the algorithms on that. So number of algorithms in classifications are there, number of algorithms in regressions we have. So here, when we talk about the regression is about prediction. Okay, both the supervised learning, in supervised learning, we can only predict the things. Okay, from the data, the input we are giving to the machine, both classification and regression is predicting the future of the data. So suppose if you have the FDI data with you, or the import or export of any country with you, you can use the classification and the regression model of machine learning algorithm, and you can predict the future of that particular import and export with the other countries. It will be very effective for you. Now, the regression is used to predict the continuous quantity. But when we are going to use the regression and when we are going to use the classification, we need to classify that. We need to identify that. How can we identify that? If we have a quantity data, continuous data, the variable is continuous, that has an infinite number of possibility, then we are going to use the regression. Otherwise, we will not able to use the regression. For example, if here I have given you the example, the weight of a person, maybe 180 pounds, 10 pounds, 1.1 pounds, or many number of possibilities of weight are there. It is limitless number of things we can collect exactly. So the continuous variable is there. So here we are going to use the regression. We can predictive analyze that on certain weights of age, what will be the weight of proportionate weight for that particular age. We can predict it. We can find it using the regression algorithms. Understand?
Sir, understood, sir.
Sir. Yes, sir.
So up to here, if you have any kind of queries, you can ask me, because here step by step we are clearing the things. So we have discussed the classification and regressions. In that, if you have the data and all that things, you can apply, understand your data and find out which techniques you can use for the machine learning. Now, the second thing that I have discussed with you is association and clustering. So more examples I'm giving to you so that you can understand the type of data you have and which model you can apply for your research. So association problem basically involve discovering a pattern in the data and the co-occurrence in the data. Okay, so suppose you have a relation, you have a data of someone wants to buy something from the market. Okay, suppose you want to buy the tea. Okay, and you want to find out what will be the price for the tea and how it will impact the price of the coffee. So there is a association between the tea and coffee, because if we take tea, you will not going to take the coffee. If you take the coffee, you will not going to take the tea. So there is an association between, inverse association between the two. Similarly, you can take also the example of jam and bread. If you are buying the bread, it means you are going to buy the jam also, because it needs. If you are going to buy the mobile, you need to buy the charger also. Now the Apple has do the same thing. They have put it out the mobile chargers from their boxes, so they know that the consumer will buy the charger. Without the charger, they will not use the phones. So this is the thing that so there is using these information is just to make you understand that how the association problems has been identified. So what's the, if you have a data like that, so you can use the association algorithms of machine learning and finding out association and co-occurrence of that particular data, which are similar to each other. Now, in case of clustering, what we are going to do is use of for cases that involve target marketing. Suppose you are giving with a list of customers with certain information. So on that basis of the customers list, you can classify the customers. You can categorize the customers. You can make a clusters of the customers. This particular age of groups, people will wear these kinds of things. This particular, so for the marketing purpose, we can categorize the customers on the certain informations. And now Google AdWords, we are using it. Google AdWords very much popular these days for the advertisements. So what is that? It is a artificial intelligence. This is a machine learning that making you with your interest, they are making you the advertisement like that. Understand?
Yes, sir. Yes, sir.
Now, the last one for the reinforcement, what kind of data and what are the examples of the reinforcement learning? The reinforcement learning makes the differences in the input itself and depend upon the actions that we are taking. I'll just give you the example of the reinforcement learning. Suppose in front of a newborn baby is there. Okay, so the newborn baby is totally unaware about the circumstances. They are not able to take the decisions. They even not able to do anything in this world. Okay, it's just like a human has been alone in a particular island. Okay, so what that baby is going to do? They are going to collect the informations through their eyes, through their ears, through their skins. All the sensory things will collect the information for them, and they are collecting the information for a very long time. And from that information, they are experiencing. They are getting experience. How they are getting the experience? Because from that information, they get a good experience, and on that good experience, they get rewards. And they are collecting the better experience, and from the bad experience they are going to be punished. Okay, suppose if the child is touching the fire, firstly it was not aware that it is a fire, it will burn, but he is going to catch the fire. But when he was burned with that fire, second time he will not go. So this is the information through that it is working. Same application is going to be implemented in the reinforcement learning. In that, we are training the machine without giving any information. We just making the machine and as an agent and put it on a surroundings information. And the machine itself collecting the informations on its own. And then they are, on the basis of their information, they are creating experiences. The experiences in terms of rewards and punishment. And then after a period of time, when the information is sufficient and the experience is sufficient for the machine, this machine is able to take the decision. So this is the higher version of the machine learning. So here the reinforcement we are talking about. Now, what type of data we are using for that? Supervised learning, unsupervised learning, and reinforcement learning. So as I told you, the machine will be provided with a label set of data in case of supervised learning. The data is labeled and output is also labeled. All the machine has to do is to use that algorithm to classify them. Okay, the output of the algorithm before it start working on it are being identified. An example is classifying a data set into either a cat's or a dog, as I've given you. All right. So if algorithm is fed an image of a cat and image is labeled as a cat, similarly, we have image labeled as a dog, and then identify the machine as a this image is a dog. So guys, this is how how we are model is taught. It's told that this is a cat and this is labeling as the cat, and the algorithm is taught. It has been tested using a new data. So if we providing again and again the images, any images, the machine itself classifies this is a dog, this is a cat, this is a dog. If we are giving them the dog image and saying it is cat, they will reject. Okay, so this is the classification in supervised learning. It is like doing that. In unsupervised learning, the machine is only giving the input data. So here we are not going to tell them the system where you have to go. We are just giving the images to them. Suppose here in supervised learning, we are giving that this is cat, this is dog. But here we are not telling them that this is cat, this is dog. We are just giving them the images. And on the basis of the similarity of that images, suppose the eye is similarity, eye in the similarity in cat. So classifying on the machine itself, classifying these datas and then putting into the different boxes. The cat images in different boxes and dogs images in different. But we are not going to tell them how the machine we have to make you understand. So they're making the clusters of dog and cat images. Similarly, I have told you in case of reinforcement learning, there is no predefined data. In that, we are not going to give the data to the machine. In that, input depend upon the action taken by the agent. Here, the machine will be acting as an agent because he is going to collect the information. Now, these actions are being recorded in the form of matrices to the machine, and that is can serve as a memory to the agent, and it will be stored into the memories of that in form of matrix. So basically, the agent explores the environment. It will collect the data and was then being used to get the output. And reinforcement learning has no predefined data given to the machine, and agent does all the work from the scratch. Understand? Now here comes the training. In machine learning, we are putting the training to the machines. In machine learning, we are training the certain data of we are using for the train, and the rest of the data we are going to predict. Okay, so in supervised learning, the training phase is very defined, very defined, and very explicit and very short also. Okay, in terms of training, the supervised learning, the training is very short and well defined. That, as I told you, the data is given to the machine is very labeled. Okay, that we are using in case of that cats and dogs. So the training data acts like a teacher. The data act like a teacher or guide to them. This is this data. This is this data. This is this data. Once the algorithm is well trained, it is being tested. Training and testing is being done on that. So in supervised learning, training is very short but predefined and explicit. But in case of unsupervised learning, the training phase is very big. Not very big, but big, because machine is only giving the input and has no feeder of output. Okay, so the output has been done by itself by the machine. So there is no supervisor here and no mentor over here to find out give the machine to have that which kind of data this is going to be have. But in case of reinforcement learning, we are not giving data to the machine. Okay, so what we are going to do, we are going to put the machine into the environment, particular environment, and itself getting the information. So that's why the training phase in reinforcement learning is very big. Understand? And machine has to learn everything on its own. They start storing and collecting the data.
Sir, your voice is breaking.
Hello?
Your voice is breaking.
It's
Participants, please wait for a few minutes. Sir will come. Checking the
Dear participants, please wait for a few minutes. Since we have some technical glitches, we are trying to resolve it.
hello. Hello, I'm audible to you.
Yes, sir.
Are you able to see the screen?
yes, sir.
Yes, sir.
Okay.
So, we are discussing the aim of supervised and unsupervised and reinforcement learning. The aim regarding the
The
goal of
screen
the
is not visible, sir.
what?
Screen is not visible.
Wait. Now it's visible.
Yeah, now it is visible.
Okay, thank you. So we are discussing the aim of the supervised learning. What is the aim of that particular supervised learning in machine learning? The aim is to forecast. Okay, we are when we have a data and we need a forecasting on that. We need to predict something from the data. Suppose we have a 10 years of data we have. Okay, and now we are from that we have to take in decisions in 2021. What will be the impact of the COVID-19 in 2021? So we can predict this supervised learning. So here the aim of the supervised learning is prediction and forecasting. Now, when we are talking about the unsupervised learning, the aim of the unsupervised learning is discovering patterns, the hidden patterns in that, and existing useful insights from the data that we are not able to see, because the data is so huge, and for the human it will be difficult to find out a pattern in that. So the machine will make you to find out the certain patterns in that. Okay, suppose if you are finding out from the recent pandemic, what will be the what are the things that is going to be affected by this pandemic. So human can also only think some few associations with them. Suppose the income of the humans has been affected, the unemployment is there, but overall we are not able to find out what will be the impact. So if we collect the big data from the surroundings and we interact with the machines and putting it to the machines, so machine will discover a hidden pattern that we are not able to see. So like that, we are in research, we are using this unsupervised learning to finding out the hidden variables, associations between the variables of different suppose the dependent variable is there and independent variable is there, and we are finding out a pattern on that. Then we use the supervised learning. Reinforcement learning here, as I told you, all the information is being collected by the agent, and the machine will work as an agent into the environment. So the machine is having an intelligence of that, how to collect the data and how to find out the informations from that. So as I told you, the human child is very clueless when it comes to the world. Similarly, the machine will be clueless when it enters into the environment. Now, slightly slower and slowly, they are going to interact with the environment and explore the environment and start learning it from the mistakes it commits and basically learn from its experiences. So this is the aim of this reinforcement learning and all that thing. Now, what are the approaches and algorithms that we are going to use for the machine learning, especially with these classifications like supervised, unsupervised, and reinforcement? So supervised learning, it's quite simple, like that I mentioned. Algorithm has to do is only to map the because the data is already mapped, okay, labeled, sorry. The data is already labeled and output is also labeled. Just we need to map the things with the input and output. So algorithms are designed to map the data only. But in case of unsupervised learning, the algorithm has to find a pattern in data trends and keep exploring the data until it reaches to the output. Okay, and in case of reinforcement learning, the machine is going to be use the trial and error method. The trial and error method, which makes you suppose you are playing a game, okay, and in that game, what happened? Suppose you are playing a PUBG nowadays. Everyone is using that PUBG. So in that PUBG, what happened when you die, you again having a chance to do it. The same mistakes what you have committed in the first life. In second life, you will not commit the same mistakes. You reluctant to commit these mistakes. Similarly, the third life, you are using it to get to the perfection. Similarly, is case with the machine in case of reinforcement learning. So they are going to try the algorithms again and again until it comes to the maximum reward. Maximum reward means the good that we need to achieve. Understand?
Yes, sir.
Yes, sir.
Now, how the machine is going to be when the machine is interacting and the machine learning is using that algorithms, how that machine is going to take the feedback. So in case of supervised learning, there is a proper supervision of a teacher is there. As an agent, as a teacher, we are continuously supervising it. So supervising learning, in that there is a direct feedback mechanism. Since the machine is trained with the built input and output. So there is a direct feedback. If there any kind of mistakes the machine will commit, you can stop that on that particular time. So direct feedback is there. But in case of unsupervised learning, there is no feedback mechanism because machine is unaware about the output during the training phase. Machine does not know what will be the output. Suppose if we are giving them the cats and dog images to them, machine does not know which one is the dog and which one is the cat. On the basis of the similarity only, they are going to classify them. Okay, so there is no feedback system is there. In case of reinforcement learning, the feedback is in the form of rewards and punishment. In reinforcement, there is a feedback. The machine that himself understand, because no one is going to tell them which one is good, which one is bad. Machine itself identify it, which one is good and which one is bad from the environment, and is taking suitable actions on that. So this is, suppose if you are going to gain gain more coins from the rewards, if you are playing the games, so there is a coins in that. You are collecting that coins as a reward. So maximum rewards you will get and maximum perfection you will getting into the game. So it is like that in reinforcement learning. Now comes to the various algorithms that we are using. As I told you, in supervised learning, algorithms like linear regressions, which is mainly used for the regression problems, is there. It also has algorithms like support vector machine, decision tree, and we can use in terms of supervised learning. Okay, so unsupervised learning, we have algorithms like C-means is there for cluster analysis, and algorithms like a priori and association rule is mining to deal with the association problem. So in supervised learning, regression and classification algorithms comes, and in unsupervised learning, we have association algorithms and classification algorithms like C-means and priori, like a priori and association rule is there. Reinforcement learning is very explored recently. It is very new, and only few algorithms has been developed. But in future, you will come up a lot of algorithms in reinforcement learning. And recently included the Q learning and the state of action, state reward action algorithms we have in there. Some more algorithms I will give you and the last of this lectures, so that you can understand how can we make the algorithms. So now, in a very nutshell, I will give you the problems and their algorithms in this slide. Okay, so you have you are come across the confusion. Your confusion may be removed. So if you have a data and a question whether A is true or B is true, we can use the classification algorithm. Understand? If you have a data that you have to find out how much and how many, in such a case, we can use the regression algorithm. Okay, so how much will be the price, stock price, we have to predict what will be the stock price in future, then we can use the regression algorithm. Suppose if something weird it is there and you will not identify what things are going in the giving in this data, and the data is not labeled, you just put a scrap data is there, okay, and you don't have any things, then we can use the association algorithm for that data. How it is organized? Suppose you have information is there, but you will not able to organize that information. Which information is for which person and which information is related to which information, you are not able to identify that. In that case, you can use algorithm of clustering. Okay, and in case of reinforcement in algorithms, what should I do next? Suppose if you are not able to decide what things I can do with this data, you just give this data, put the machine into that data, the machine will let you know what should I do the next. Understand, everyone? So these are the methods of algorithm where can you apply these algorithms. the machine learning, especially the classification used for the image classification, identify fraud, customer relation diagnosis, and regression. We can use advertising popularity predictions, weather forecasting, market forecasting, estimating the life expectancy. And unsupervised learning, we can dimensionality reduction, big data visualization, meaningful comparison, all these things we can use for that. As we are having a shortage of time, so I'm just, this is all we have discussed with you. This is the few algorithms that machine learnings we are using. Here you can see the deep learning algorithms is on the top, then regression algorithms is in the below, clustering is there, algorithm is there, and dimensionality reduction algorithms are there. The number of algorithms are there. In neural networks is there, decision tree is there, Bayesian approach is there. So all are categorized there. You can find out which is suitable to you regarding that data, and you study that particular algorithm, find out that algorithm, and you apply with the machine learning help. Understand? Everyone understand?
Yes, sir.
Yes, sir. Yes, sir.
Okay, so this is all about the today's lecture, and what the artificial intelligence and what will be the future of that artificial intelligence. For that, I'm just giving you a 1-2 minutes video for you. So just with that, I will end up with the session.
Google, Facebook, Apple, Microsoft are all moving ahead at a great speed in improving this artificial intelligence software. So it's very exciting. Software is going to solve that, where it'll look at all the new information and present to you, knowing about your interests, what would be most valuable. So making us more efficient.
We're focusing on what we talked about, on autonomous systems. And we sort of see it as the mother of all AI projects. So autonomy is something that's incredibly exciting for us. We'll see where it takes us.
Wouldn't it be wonderful if someday we got to the point where there were robots every place, they were running farms, they were running Apple, they were running Berkshire Hathaway, and all you had to do was one person could punch a button at the start of every morning, and all the goods and services that we're getting now would be turned out by robots.
It is seeping into our lives in all sorts of ways that we just don't notice. We're just getting better and better at it, and we're seeing that happen in every aspect of our lives, from medicine to transportation to how electricity is distributed. And it promises to create a vastly more productive and efficient economy. And if properly harnessed, can generate enormous prosperity for people, opportunity for people, can cure diseases that we haven't seen before, can make us safer because it eliminates inherent human error in a lot of work.
Artificial intelligence is going to be extremely helpful, and the risk that it gets super smart, that's way out in the future, and probably we're talking about. But now what we're seeing is that for the first time, computers can see as well as humans. That's pretty incredible.
NHTSA did a study on Tesla's Autopilot version 1, which was relatively primitive, and found that it was a 45% reduction in highway accidents. And that's despite Autopilot 1 being just version 1. Version 2, I think, will be at least 2 or 3 times better. That's the current version that's running right now. So the rate of improvement is really dramatic, and we have to figure out some way to ensure that the advent of digital superintelligence is one which is symbiotic with humanity.
AI is probably the most important thing humanity has ever worked on. And I think of it as something more profound than electricity or fire. And anytime you work with technology, you need to learn to harness the benefits and while minimizing the downsides. stepping back, when you think about, a lot of problems in the world today, it's because we typically have a constraint on resources. AI, for the first time, I think, over time, offers a different construct. Things which are constrained and look like a zero-sum game today may not be so in the future. Take education, for example. It's really difficult to educate people in a cost-effective way. AI may fundamentally change that equation. It may make it possible for us to have clean, cheap, renewable energy for the future. So I think a lot of things will play out in more positive ways than people think.
I think probably by end of next year, self-driving will encompass essentially all modes driving and be at least 100 to 200% safer than a person by the end of next year. We're talking maybe 18 months from now.
The idea that there's going to be a general AI overlord that subjugates us or kills us all, I think is not something to worry about. I think that is overhyped. First of all, we don't know, we're nowhere close to knowing how to build a general AI, something that could set its own objectives. But second of all, I think it's unlikely that such a thing's first instincts would be to exterminate us. So I'm optimistic about that one, and certainly don't think we need to worry about it today.
So this is all about the today's AI and this what we have called as machine learning. And I hope that you have a better understanding of this machine learning and AI. So regarding this, if you have any kind of queries, I know that this is a very introductory and very basic understanding of machine learning and AI. But I think it will be helpful those who are doing the researches in that researches, they can able to use that machine learning methods and algorithm after this. So if you have any queries, you can ask me. Come up with that queries.
Thank you, sir, for your wonderful presentation. Now we request participants to ask their doubt or questions to sir now. Either directly or in the chat box answer. Participants.
You ask directly.
Okay, participants.
Sir, this is Aishwarya from Vistas. Sir, as you showed us the various algorithms on the on undergoing machine language, some of the algorithms which we are already using on research nowadays for our research solutions and problems. So we are in track with machine language. Is it the using of this algorithm on different platforms is what we need to learn more?
Yeah, definitely. You are asking very good question that you are using, suppose when we are talking about the regression classification. So I told you in the beginning that when in before 1980s, when the machine learning was not introduced, it was already think that the machine learning has been treated as a robot and mechanical task that putting the buttons they will do. But after it comes and in touch with the statistics, the probability theory has been used in that, and various statistics methods has been used in giving a logic to the machine learning, giving an introduction to the machine learning, because now they are going to use certain logics using with that. So the when we are using that statistics portion in machine learning, it's also the regression we are using is the same regression that we are using in machine learning. But when we are using the machine learning, also the data that we are going to use for that regression is slightly different. The method we are applying is same, but we are using in a different method. So the regression is there. We are putting the best fit, finding out the best suitable prediction for that regression. So you are asking the same, but the thing that you are asking is that whether the regression that I'm using for your research we called it as a machine learning. I told no, that will not be a machine learning. There is a difference between statistics and machine learning.
So as a researcher, I am knowing lot of algorithms and all the classification methods. So what is that I should take a next step to learn to get a complete knowledge on machine learning?
To get the complete knowledge of machine learning, you definitely have to study that things. Especially you decide what is your type of data. As I told you, which kind of machine learning methods you have, whether your data comes under the supervised learning or unsupervised learning or reinforcement learning. So first you go and identify the type of data that you have. And then on the basis of type of data, there are number of algorithms are there. Suppose you are using a supervised data in your research. So you can go and find out which is the suitable algorithm for your data. Whether you go for the regression, there are a number of regression algorithms is there. If you are going to use the classification algorithms, there are a number of classification algorithms is there. Bayesian approach is there. Random forest is there. KNN is there. Number of algorithms is there. So it is depend upon data. After identify the classification, you put all the algorithms and find out which one is giving you the best result. Because the thumb rule is that you have to your result, your prediction should be come up with 80%. If it is not 80%, that result will not be acceptable. So depending upon the data that you have, if your results are coming, suppose KNN is coming 80%, that will be acceptable for you. Machine learning, vector machine is their classification. For the classification, there is an algorithm called vector machine. You can use that also. Vector machine algorithm. If the result is coming 80% accuracy, with the 80% accuracy, then your prediction will be good for that. Like that, you have to study your data, and then on the basis of your data, you have to learn that algorithm.
Thank you, sir.
Thank you.
Thank you, sir. We voluntarily need 2 or 3 participants to give feedback on this session.
Sir, I have a question related to my research work that I have used multiple regression analysis technique for predicting the stock market of India. But using this technique algorithm, we can only predict whatever the historical data is available in the stock market. But nowadays, when a new impact, new news will come, new market strategy has changed, then which algorithm we will incorporate them so that we can also incorporate the sentiment analysis in our research?
So sentiment analysis, if you are taking with the stock prices, there are 2 different fields, sir. First of all, because you are talking when your data is a stock market, you need to do the supervised learning on that. You are going to predict the things. In supervised learning, we are predict. But when we are talking about the sentiment analysis, there is in that data you need to find certain associations, because that data is unlabeled data and you need to find certain association. So first of all, you classify your data, what kind of data, whether it comes under the supervised learning, because stock prices, I know that it comes under the supervised learning and you can use the algorithms on that. But when you are going to the sentiment analysis, you have to link the data to the unsupervised learning. So unsupervised learning is association and clustering is there. So on that basis, you have to identify the data and type of algorithm you need to use. Understand?
Thank you, sir.
Is there any feedback from participants?
Good afternoon, sir. It was a nice session that the topics what you have discussed is anonymous, but you try to explain it in the simple form which can be understood for the beginners. As a beginner for AI and new concepts like machine learning and deep learning, it was an enriching session for us. Thank you so much, sir.
Thank you, sir, for giving the feedback.
Thank you. To conclude the session, I now invite our department PhD scholar, Mr. Sundar, to propose vote of thanks.
Yeah. Thank you, sir. Thank you for your wonderful speech. It is my profound privilege to thank Dr. Abuzar Nomani, sir, for his efforts towards artificial intelligence and machine learning, its history, fundamentals, and basic concepts. He has shared videos and he has explained the history of the concept, found very particularly interesting. I must mention our deep sense of appreciation to Dr. Abuzar Nomani, sir, for his explanation of machine learning and deep learning. Furtherly, we are grateful to Dr. Abuzar Nomani, sir, for demonstrating his fundamentals and basic concepts of deep learning, reinforcement learning, and machine learning. I may like to express our sincere thanks to Dr. Nomani, sir, for giving an excellent coverage to all the concepts which we have given to you. And we also would like to acknowledge our gratitude to our professor and head and the faculty members, Department of International Business, for the arrangement of this FDP. We are inspired by your great words, Dr. Abuzar Nomani, sir. Thank you, sir.
Thank you, Sundar sir. Okay, participants. We'll move to the next session after lunch. I request all of you to join by 2:30 for the next session. Thank you, participants, for your present.